Hello and welcome to our webinar. Today we'll be talking about the road to adoption of industrial exoskeletons. My name is Megan Kennelly. I'm the head of global marketing here at German Bionic, and I'm excited to be joined by my colleague Andrew Mason, analyst at German Bionic, and Adam Norton, associate director of the Nerve Center at the University of Massachusetts Lowell. Thank you both for joining me today. All right, so just a quick housekeeping item before we move on. Just wanted to let everyone know that there is a chat function in the webinar. So if anyone has any questions throughout, our colleague Marlise will be in the background, either sharing those questions with us to answer live, or we can answer them in the chat. So let's get started. Before we dive into the topic, wanted to give a quick background on German Bionic. German Bionic is a European robotics firm. We are based in Germany. However, we have offices throughout Europe, Japan, and North America. We are a company that focuses on the integration of humans and robotics to help support workers and change the future of the workplace. We got our start with our very first exoskeleton back in 2017. And have been working with customers throughout to continue to advance our exoskeletons focused on the lower back. You'd be surprised to hear that about 619 million people worldwide had lower back pain in 2020. That's nearly 10% of the world's population. And by 2050, that's expected to increase by 843 million. And that's coming from the Lancet. We are absolutely trying to tackle that issue when it comes to lower back pain with our exoskeletons that help provide not only support for workers, but giving them additional power when they're doing frequent continuous lifts. Now, without further ado, I'd like to hand it over to my colleague Andrew to give us a quick background about himself and dive into the market of exoskeletons and what's going on in terms of standardization. Over to you, Andrew.
Okay, thanks very much, Megan. I'd just like to preface the next part by giving a brief introduction to the kind of work that I do. So as an analyst, I'm looking at the market in general, and that includes how we can increase the adoption of exoskeleton devices. And part of that also ties into the work that Adam is doing in terms of standardization. So we are very much approaching this topic as a manufacturer. Obviously, we have customers that we have to work with, and a big part of what we do is trying to overcome the challenge of integration. So how do we integrate our devices with our customers that have very different problems, very different customer sites. Even one company across all of their sites may have different issues. So if you consider, a warehouse in Texas has to contend with temperature, for example, or the weather, which might be quite different to a company in Canada. And even within those sites, different processes, different personnel, different use cases, different workstations. We're trying to come to terms with all of that. And I think it's a good thing to point out that just for all intents and purposes, during this, there are broadly two types of exoskeleton device. One is medical, so I'd like you to point your attention to the right under the medical section. These devices are more in terms of rehabilitation. So you can see there are broadly two types, upper body, lower body. So it's usually after the fact when somebody already has some kind of spinal cord injury. If they've suffered a stroke, then usually they're in a clinical setting, so in a hospital, and these devices are helping people rehabilitate after those kind of injuries. But for the purpose of what we do, we are mainly looking at industrial exoskeletons, and that's where you look on the left. So those would be mainly workplace devices, and they're usually preventative. So what we're doing is trying to prevent illnesses. Those illnesses are workplace musculoskeletal disorders, or MSDs. So basically what MSDs are injuries of muscles, nerves, tendons, joints, cartilage, or spinal discs. And I think it's one thing to point out is that the pathology of MSDs is not really very well understood. It can't really be fully explained because obviously there are lots of contributing factors. Some people have hereditary illnesses. Some people have congenital illnesses, so from birth. Some people who've acquired pathological processes throughout their life, if they've had a tumor and overcome that, if they have some kind of thrombosis or fibrosis. So there's lots of things to contend with. We are building these devices for human beings. And one thing to say about human beings is that they're quite unpredictable, you know. So that, you know, impairments might come from infections, inflammatory, degenerative processes. And I'd also like to point out that obviously we have an aging population at the moment. We also have shrinking workforces. We have shifting consumer expectations, especially after COVID. A lot of people are working from home, spending a lot of time at home, ordering things on the internet and expecting it to be at their door the next day or, you know, a few days after that. And obviously that is an enormous ask. I mean, we think about doctors and nurses, but some of the key workers that we don't really consider, so those logistics workers, people working at airports, all of those people who had to take a lot of the strain on their own backs to try and solve this problem. So yeah, exoskeletons are devices that are showing great potential to actually solve this issue, to prevent the musculoskeletal injuries. I mean, if somebody already has some kind of degenerative illness, obviously it wouldn't be very nice if they get another one through the work that they do. So it's very important to protect people, and we're all probably going to get at least one if we're lucky throughout our lifetime. So what can we do to extend life, and what can we do to improve life just during the time we're all here? I'd just like to add as well, there is no such thing as 100% certainty. There's no such thing as zero risk. Again, we're all going to die at some point. We're probably all going to get some kind of illness, but there are some that are preventable. So exoskeletons are proving in tests at reducing muscular activation during tasks, reducing fatigue, task difficulty that's perceived by the workers themselves. In some cases, although I find it quite spurious, improving. But workers are reporting that these devices really are helping them. And I think we have a great opportunity here to actually protect the workers that we do have, protect them into old age, and make sure that they can still go home at the end of the day and play with their kids, let their kids there and live a full life. And this is, again, when you think about these kind of biological consequences that come with working with human beings, you also have to consider the different processes in which they work. Different types of these MSDs. You can see there are very different types of devices that come out.
Hey, Andrew. Sorry to stop it, but your audio is going in and out for me.
Really? How is it now?
That's better.
Is it better? Okay. Yeah, so these devices have been specially designed to solve certain problems within the workplace, and some of those affect the lower back. Some of those affect the neck and the shoulders, specifically in overhead tasks like in manufacturing, production of automobiles, and some, you know, when you're stooping or when you're in a specific awkward posture position for an extended period of time. So also in automotive manufacturing, maybe you're working on the tires, putting the wheels on the vehicle. Then this can also be a consequence that you might get some kind of musculoskeletal injury. Yeah, and so in solving these issues, what has happened is that obviously each company, and there are about, I think there are over 100 manufacturers of exoskeletons at the moment, solving very different issues, all having taken different technology choices to approach those problems. Some can be passive, some can be powered, and I'll explain this in a moment. Some pneumatic and some soft. Yeah, Megan, can you take me to the next slide, please? Right, so if we focus specifically on lower back exoskeletons, because obviously that's our area of expertise, There are different technology choices that have been made by different manufacturers to solve the different tasks that are being presented, so the different problems that our customers have. We develop our products in very close proximity to our customers. Obviously, we're getting a lot of feedback all the time, so we work alongside the workers, and we try to implement those changes as we go forward. If you remember the timeline from the start, we can, show the changes that we have made in terms of trying to improve our device so that the workers are happier and adoption rates are higher, but most importantly, solving the problem that presents itself. So generally, they're powered. We have a powered device. It uses a battery and motors, and we have designed it we're starting with logistics, but also other use cases as well. Very, sometimes heavy loads, but chiefly high intensity, so repetitive lifting. There are also passive devices, such as those using a spring and damper, and those generally can be used. It may also be used alongside powered devices in certain workplaces, like I've already said, and that could be slightly for different use cases with slightly lower intensity of lifting, but that's up to the workers themselves to decide, and up to the customer to decide, what works best as they go through their processes, as they implement their processes. Also, there are textile ones, which are a little bit easier to put on and take off, maybe a little bit more flexibility, so they can be used in very tight spaces, for instance, in aerospace in the cabin hold. Also, if you have to use machinery, if you have to use a forklift truck or a van, for example, you're a delivery driver, then it's quite easy. You don't have to keep taking it off all the time. And so those are seeing some success as well. But I think the main thing that I'd like to stress is that each one of these devices has been developed in close consensus with the customers and in close consensus with the workers and with all of the stakeholders within the company. So safety officers, for example, occupational safety and health representatives. Yeah, can I get to the next slide, please? Yeah, the current method that's used by exoskeleton manufacturers, so whenever we go to a customer site, we're trying to identify, it might seem like a counterintuitive way of working, but we're always generally trying to negate the needs of an exoskeleton. So this is the common approach, is the NIOSH hierarchy of controls. This is what our customers will use as well, what their safety representatives will use. And there are various steps, so there are 5 steps. The first one is elimination. You try to eliminate, if you notice that a hazard exists, is there any way that you can remove it from your workplace altogether? Is there any way that you can substitute the material or process so that it reduces the hazard? And this is where there's a conversation at the moment relating to exoskeletons. Are exoskeletons considered to be engineering controls? So, for instance, if you consider pallet trucks or other devices that may be introduced to either prevent noise or reduce load, just to help the workers in any way, the guardrail system, for example, that's something that is considered. Obviously, there are also administrative controls, and we work alongside administrative controls as well. So even though there's an exoskeleton introduced, you may want to think about task rotation. Are you going to help the worker by changing around the task, or seeing what order of task rotation works the best? You can do that by asking the workers how they feel at the end of it, or measuring objective biomedical parameters, and we'll get on to that later. And finally, there's personal protective equipment, or PPE. So this is the traditional kind of protective clothing, which would be safety glasses. And I think obviously, as exoskeletons are worn devices. And a lot of them now, especially with those textile devices that I showed in the last slide, are starting to resemble more clothing. So there's a real question, and this is something that our customers ask us a lot, and we hope that some kind of standardization effort will help to clarify this. But again, I think the best way to approach this is the way that it's been occurring so far, which is to look specifically at the tasks. So we'll go in at the customer side, and we'll really try to see if an exoskeleton is actually necessary, or even if our device is the best device to solve it. And we may even provide certain recommendations elsewhere. And I think this is where also a standardized way of measuring different devices would be very helpful. So in terms of the road to adoption, obviously the work that Adam's doing in the ASTM, the work that's being done around the world, and I'll show that shortly, could be very helpful. And if we go on to the next slide, I can delve into that. Yeah, so in terms of standardization bodies, again, there seems to be quite a lot of activities that are occurring around the world. Some of them, like DIN in Germany and Senelec, don't seem to be actually publishing standards currently. They have working groups where they seem to be focusing on sometimes the more technology specific consequences, or how can we ensure safety. And I haven't seen any published standards there yet. There are published standards from ISO and JIS. I think the Japanese standard goes back to 2014, where one of the first manufacturers really came from. And as a result of that, there wasn't a huge amount of participation, as you can imagine. But those are quite similar. Those standards are in terms of how can you measure performance. So how do you prove to a potential customer that the device is really working, or how can you measure the amount of support? And it was separate to any biomechanical, so biomedical measurements that could have been taken. It was simply looking at the device itself. And more recently, ASTM are much more comprehensive in looking at different measurement methods, so methods of measurement. And yeah, hopefully that's something adds to the proof. So when we really have queries, we can say, okay, we use this standardized methods, and we can prove that it works because this is the industry approach and it's been approved. Although we would like more clarification on how exactly that's being done at the moment, and how we can use those kinds of measurements to prove to our customers that the device is really working. And maybe that's something that's done on site in the integration and implementation process, where we work with the customers to develop a kind of testing methodology on their side, because obviously, like I said before, it's very site specific. Each use case is very different. So sometimes it might need to be that you craft a custom approach that works for them and works for their workers and works for all of their stakeholders. And this is more recently where a very interesting standard has come about that we'd like to highlight. I'd also like to get Adam's interpretation of AFNOR as well. It's from France, and it focuses much more on this kind of integration. So it's a guide for how those who want to integrate exoskeletons into their workplaces can actually do it, a step-by-step guide to success. So specifically, how can you implement them? How can you actually be successful? And obviously that involves yeah, if we go to the next slide, I can delve into this more. Oh, yeah, so maybe not. Yeah, these are some of the standards that we've seen so far that are very specific to the work that we do. And I'd just like to point out that obviously we're not really sure how these standards are aligned at the moment. And we definitely want more clarification on that. That's certainly something that the customers that we work with would like to know as well. What we want to avoid really is a patchwork of different standards where no one's really sure of the work that's being done, and maybe there might be some kind of overlap or contradiction. So I think some kind of clarification on how we can communicate that would be helpful. And it is my knowledge currently that those standardization bodies would be aware of the work that's being done in other bodies and would be actually trying to avoid that and would be trying to align, so building on previous standards. But obviously that's something that would be nice to hear from the horse's mouth, as it were. Yeah, so the most recent one that I've seen is the AFNOR standard, which was published in 2023, so last year. Yeah, Megan, please. Yeah, so as I said, it's been quite helpful for us, and I think it would be quite helpful for anybody who's looking at integrating an exoskeleton, because it's quite high level. In what I mean is that it's not so comprehensive and it digs so far down into the detail that it might be not applicable to certain sites, certain workplaces, but it gives the stakeholders within a workplace the freedom to say, okay, I know my workers, I know our processes and our ways of working, and I can use this as a guide to craft a integration plan that works for us, and it might be better for achieving success. Yeah, so it's various different steps, and as previously stated, first it's recognizing where there is a need. So usually the safety officers will be quite well aware of different potential hazards within their workplace, and will have gone through these various steps to look at how they can solve and overcome that. And there will be an identified need. So that's where they might think, okay, I've tried to overcome this in various different ways in the past. We haven't been able to. Maybe an exoskeleton can help. And we want to do a study where we want to see if the workers benefit from it. You know, if they are reporting that it does help them in their workplace, and obviously it's not hindering them too much, so they can still do their job. It doesn't affect them emotionally. They don't have any kind of emotional detachment from their work as a result of it. Yeah, and then again, we talked about different types of exoskeleton. We talked about the different technology choices that are made even within different use cases of exoskeleton design. And then comes the selection of an exoskeleton. And so the standard also talks about different ways that you can avoid, for instance, not trying to get as many devices as possible and measure as many as possible. Really trying to understand which device has been specifically designed for the use case that you have and for the potential hazard that you have. Maybe measuring a few different technology choices, but ultimately what you want to avoid is that you overload the workers and then they have some kind of emotional detachment and they ultimately are not pleased with moving forwards with the study. Yeah, so that's all factors into the design approach. You want to think about the psychological welfare of your workers, the biomechanical, and the physiological. So it's not just, okay, is it going to reduce muscular strain? Is it going to reduce pain? It's a simple case that with a lot of older workers especially, they resent having to wear any kind of safety equipment. And even if you go into a boardroom and you tell everybody to sit up straight with a correct posture, or if you've been watching me throughout the course of this webinar, you're going to see that we don't always do it. Again, humans are unpredictable creatures, and sometimes we favor short-term comfort over long-term safety and prevention, which is something that we also have to overcome. And this is why getting the integration right is so important. And yeah, this ties into the evaluation process. So this is where you're really going to maybe identify 1 or 2 workers, people that you hope will become evangelists within the company, and yeah, try and craft or perfect the study based on this. Because obviously when you introduce an exoskeleton, you're not just disrupting processes, but you're also introducing new ones. And this might be disruptive to the workers, so you have to make sure that it's as smooth as possible. And that's why maybe, you know, it could be a laboratory study that you do first to try and improve the technology. Maybe that's in the previous stage 2 of the selection of the exoskeleton, or reading existing studies that have been done. But yeah, it's really important to make sure that you work with one person, maybe just a handful of people. That's up to the professionals themselves to decide, and create an evaluation that works. And don't be afraid to make changes or you know, change it along the way, because that's always something that might come up. And ultimately then deployment. It's an ongoing process, just like with manual handling, how it's done at the moment. You're constantly having to revisit different work sites and and training is an ongoing process. It doesn't stop. Once you introduce an exoskeleton, you're constantly having to you know, maybe change course or maybe tweak and change along the way. You may also want to introduce ergonomic changes, revisit your hierarchy of controls, but it's all part of the integration. And I think this approach seems like quite a decent approach. Again, it's one standard. It's not. So if we go on to the next slide where we look at the ASTM, I think this is where Adam can really come in and offer some value, because there is quite a lot of different working groups. So it'd be really good to hear, one, does the ASTM, oh, well, this is part of the evaluation. I mean, you can go back to so just some examples of evaluation. I think Adam would also touch on this in the work that he's doing. So when you're crafting an evaluation, you're going to look at electromyography, which is measuring the electrical activity in the nerve stimulation of the muscles. So then you can measure muscular strain, or at least put some data to it. I think it's very interesting to hear how what Adam's experience has been on this front, because I know that especially with EMG testing, it can be very difficult to perfect, and there can be a lot of problems that come up. Obviously, people sweat, the electrodes might come off. Not everyone finds it very comfortable. There are different devices, so some are better than others. Sensitivity might be different. Some people might have more body fat. You know, there are different BMI things to consider. So that would be quite interesting to hear Adam's perspective on. Again, another example of an objective form of testing would be ergospirometry. So this is, you're measuring the gas metabolism, the oxygen that's breathed in, and the CO2 that's breathed out, essentially. And from that, you can ascertain certain conclusions about fatigue, general fatigue throughout the workday. If CO2 exceeds, if CO2 production exceeds oxygen consumption, then you can infer that general fatigue is increasing. And that's when you might also consider in the integration of your processes an administrative change. So maybe a rotation of tasks or a rotation of personnel of workers. Those are all things to consider. And then heart rate, task performance. Again, I think task performance is a bit spurious because I always want to make the case that we're trying to prevent an illness, a disorder. We're not trying to improve the performance of the workers. That's something that we have to be very careful about, especially where workers' unions are involved. So that's all part of the road to adoption, because if there's any kind of emotional detachment from devices and unions do decide that this is something that might be used to try somehow to increase productivity rather than prevent the loss of productivity by preventing illnesses, that might be a danger to your integration. And again, obviously important to get feedback. Perceived task difficulty is very important. I think one of the biggest side effects of exoskeletons is discomfort and hindrance, but that's true of all personal protective equipment as well as exoskeletons, however they are designated currently. And I think that's always been true. There's a big thing in the UK. I don't know if you have it in the US, but especially with older workers, it's kind of this health and safety gone mad attitude where they feel, I've been doing this job for 10, 20, 30 years, and now somebody's going to come along and tell me that I've been doing it wrong. There's definitely that emotional aspect that comes into it, and those are things that we can try to avoid by really creating decent standards that help to streamline the integration of exoskeletons in our customer sites. And yeah, where's the last slide that we were looking for? So yeah, this is something that I'd be really interested in getting your just hearing your insight, Adam, because ASTM obviously looks very interesting. I think have a lot of ambition to become the de facto international standards, are very detailed, very comprehensive, it looks. So yeah, I don't really know what else I can say. This is one of my first introductions to it, actually, but I think we hope to hear more in the future and see how we might be able to get involved. So yeah, can we hand over?
Perfect.
Right, thank you.
All right, well, with the ASTM, I think perfect timing to shift it over to Adam. Adam, why don't you give us just a quick background on yourself, the Nerve Center, and then what your work at the ASTM is looking to solve.
Thanks very much. And so thank you again just for having me here. I'm happy to contribute where I can to furthering the standardization of testing for all sorts of robotic systems, which even that there actually raises a question as to whether or not an exoskeleton is considered a robotic system, which is another reason why standards are very important. But hello, I'm Adam Norton. I'm Associate Director of the NERV Center, which stands for New England Robotics Validation Experimentation Center at UMASS Lowell. I also serve on several different committees within ASTM, including just recently the International Board of Directors for the next 3 years. I'm committee chair of ASTM F45, which is on robotics, automation, and autonomous systems, which at present does not include exoskeletons. I do participate on F48, the committee on exoskeletons and exosuits that Andrew was just mentioning, and the E5409 subcommittee for Homeland Security applications and response robots. So all related to robotic systems. Other areas where we contribute include some of the Manufacturing USA institutes, including the ARM Institute. I can go to the next slide. So just a quick background on the NERV Center. We are a research center within the University of Massachusetts Lowell. But our focus, rather than explicitly on robotics development, is actually on robotics testing, research, and training. So that includes robot capabilities, human performance, and human-robot interaction, with our focus really on the evaluation of how those systems perform. We cover many different types of domains, including industrial automation, exoskeletons and wearable robots, which we'll talk mostly about today, and the application of those systems and others to applications including disaster response, urban search and rescue, et cetera. We're primarily a grant-funded research center, but we do also offer our services to external users. And just to quickly point out kind of our portfolio of research, if you go to the next slide, we cover many different types of robot systems, whether those are wearable to legged locomotion systems, both bipedal and quadrupedal, human-robot teaming evaluations, say for human-robot interaction, whether that is with an exoskeleton, with a manipulator for collaborative robotics, unmanned aerial systems, largely on small UAS, unmanned ground vehicles, largely used by public safety and military, industrial mobile robots utilized in warehouses and factory automation, and grasping and manipulation for a myriad of different uses, including assistive robotics and industrial automation. So now, while we have a very diverse portfolio, our focus again is really on performance evaluation, whether that is of the system by itself, the system interacting with the human, or the human by itself, where maybe we could augment their performance with the inclusion of a robotic system. If you go to the next slide. So before getting into ASTM F48, just in general, I think it's some good table setting to talk about the types of ASTM standards that there are. I will admit that I am less familiar with the other types of standards that are available through ISO and some of the other organizations, in that if they specify certain types of standards, then I'm just less familiar with their format. But ASTM has a pretty well-defined set of 6 different types of ASTM standards that you see, not just in F48 for exoskeletons, but also in many of their other committees. Now, I will admit also that this kind of demonstration you're about to see is using a robotic arm as an example to illustrate what each of these standards are, but I'll do my best to relate it back to the world of exoskeletons. So if you hit the next slide. So the first, and I think most important for our conversation today, is test methods. Now, what's shown on the image on the screen here is a robot arm from Boston Dynamics. But the kind of example test method we're going to use here is a ruler. Now, of course, a ruler is not a test method, but just to illustrate it, you can consider the ruler as an apparatus for a test method. It is something that you use to conduct the test method. It has a single metric, which in this case, we're going to say is the reach distance of the robot arm. So you could relate this back to, let's say, range of motion for an exoskeleton. It specifies a procedure, such as in this example, commanding the robot to perform in a certain way. And then you use the apparatus to measure some component of its performance. In this case, if it's reach distance, then we use the ruler to measure how far its arm was pushed out. Now, what's kind of key here and separates most of these standard types from each other is the type of language that they use. Now, typically, test methods include a couple different forms of rules, but the most important are the statements that are stated as shall, meaning that there are certain concepts and instructions within those test methods that must be followed in order to be compliant with the standard. Other standards, which I'll talk about in a moment, will have some shall statements, or they may not include them at all and only include shoulds, or I believe the next one down is may. So all these are important to know for the types of standards that ASTM covers. And the test methods are where I think most of what is going to benefit at least ASTM's role within this kind of ecosystem of standards, particularly around the world of exoskeletons, is really going to shine. I'll talk about that in a little bit. If you go to the next slide, we'll talk about practices. So a practice is something that should or may be followed, and really talks about a methodology for, let's say, using a test method or for utilizing a certain piece of technology. So for example, if we stick with our ruler, one type of practice could be how to fabricate the ruler, how to implement the ruler to effectively run a test method. Or, here's how you use that already specified apparatus in a test method to measure part of the environment, part of the robot system, for example, measuring lighting, measuring temperature, etc. And there are several examples of these types of standards through ASTM for measuring components of the environment before you conduct a test, recording the configuration of a robot system before you evaluate it, all things that relate back to contextualizing the data that you record, but are not necessarily required, just recommended. If you go to the next slide, we have specifications. Now, specifications, I think, are more of the types of standards that people typically think of when you talk about standards, whether it's ASTM, ISO, or any of the other organizations. These really talk about the way that something needs to be in order for it to meet a certain specification. So if we stick with our kind of ruler and robot arm concept and stick with the metric of distance, reach distance, then the specification may say, in order to meet spec ASTM E number, the reach distance of the robot arm must be a certain length or longer. And if it's not, then it doesn't meet the spec. So in this example, it's 23 millimeters, which I think that's actually 23 centimeters. But either way, it shall be followed in order for it to meet the spec or not. Now, these are really important, particularly for the types of standards that deal with safety, where maybe there's a specification on it must meet a certain threshold of performance, or it must, conform to some design feature or whatever it is. And these specifications may be pointed to by legal bodies for certain causes of action. But they're all supported by the other types of standards that you see in here as well. You may use a test method to meet a specification. You may follow a practice in order to use that test method effectively to meet the specification, etc. Okay, the next one is classifications. This is kind of an expansion on specifications where we're really just kind of talking about multiple different ways to define a class of a certain piece of technology. So again, if we stick with our reach distance example, we could say that there's a designation for a small robot arm, a medium robot arm, and a large one. Or if we want to talk about this in the world of exoskeletons, Andrew was talking about, there's passive and active exoskeletons. There's those that are for assistive applications, rehabilitation, versus those for industrial applications. There may be a classification standard, there isn't yet, that can actually specify what each of those mean. And it's likely not just a definition, because we have terminology standards, which I'll talk about in a minute for that, but more based on certain characteristics that maybe can be derived through a test method or a practice. And I'm intentionally referencing these other types of standards because something you'll see when we talk a little more in detail about the ASTM F48 standards is they are designed to be used together. There may be some standards that can work on their own, and many of them do. But they are designed as part of a suite so that they are more comprehensive in what they can cover. And just like specifications, classifications are under a shall be followed. Next is guides. This is kind of a lesser version of a practice. And there's many different ways that you can write a guide. We have some within F48 that deal with assessing risks, with selecting the types of metrics that you want to use for a study. Or if we follow our example here, here's many different types of rulers that you can use to achieve the test method of reach distance, whether it's a measure tape, whether it's a clear ruler, a wooden ruler. Again, this is a very simple example, but point being that it is not as stringent as classifications or specifications and falls under the should or may. And then lastly, we have terminology. Now, terminology is really a reference standard that all of the other standards that are specified within that committee are going to point to. And they're going to define, let's say in this example, the different parts of the robot arm, or they may define the types of exoskeletons that you are testing to say that a passive system is X, a active system is Y. And then again, just to tie back to classifications, maybe there'll end up being some criteria that you need to evaluate in order to classify it as one or the other. Now, if you go to the next slide. So here is a very high-level view. Just kind of reiterating what was on the slide earlier about the types of standards that currently exist within F48. So as of right now, we have several test methods, practices, guides, and terminology. What you're seeing on the screen here is about, I think it's about 22 standards. There are another 20 work items registered. And a work item is basically a draft standard that is under development. I'm pointing that out to say that this committee is incredibly active. Despite only being, I believe, active now for 6 or 7 years, I think it's about 2017, producing this many standards this quickly is pretty remarkable. It's a very passionate community of industry, academia, government, both makers and users of exoskeletons that are really putting in their time here. But what I want to point out is that while we don't have specifications or classifications yet, I think this is actually where we're starting to see a big need. To some of Andrew's points about maybe you're not sure how you should evaluate a system, or maybe there's a lot of different options to sift through. Even just looking at these on the screen here, you may not know, do I need the hurdles test method? Do I need the beams test method? And part of that also comes down to how each of these tests or each of these standards are constructed. In general, our standard test methods do not designate a threshold of acceptable performance. We may say that there is a threshold in order for the data to be considered valid, right? You followed the procedure. You followed all of the shall statements that you were supposed to, but the results of the test are the results of the test. Now, a specification or classification standard could point to those tests to say, well, if you get a metric of X plus, then you meet a certain specification to be deployed in a certain environment, or we classify you as one system or another. Those are still, in the future of ASTM F48, but I do believe it is what's going to be really beneficial for the community at large. And what I don't have on the screen here, but just to point out, each of these are developed in subcommittees within ASTM F48. There are, I believe, 6 or 7 different subcommittees that are dedicated to different areas within the exoskeleton and exosuits committee. So if you're interested in participating, you don't have to consider the entire portfolio. There are areas where you can specialize. Now, this is where ASTM F48 is currently at, and kind of a good encapsulation of the kind of types of standards that ASTM typically works on. If you go to the next slide, there are also other efforts within ASTM that are not strictly driven for just generating standards. These are, ultimately they're centers of excellence within ASTM. We want to, push research to standards efforts, as well as education and innovation. So there are 2 ASTM centers of excellence, one for additive manufacturing, and then one for exotechnology, or the ETCOE. Now, this is partially a research wing within ASTM that sponsors projects that can lead to higher fidelity standards, higher fidelity testing and training, certification programs, all these things that they're kind of working on. And what I want to specifically point out is an effort that actually started last year called the Exo Games. So this was ASTM's kind of first foray into, can we make a competition out of exoskeletons that can help us achieve all of these different objectives? Last year, they ran their Exo Games in the UK, out at UCLan. This year, it is being run stateside here at the ASTM headquarters in Pennsylvania. There's more information available if you search their site, but what I want to point out here is that all of these great advances that we're seeing, both in exotechnology and in the standards that are being developed, we can trickle that down into getting students involved, getting outreach involved. And that's really a sign of actually how mature a lot of this technology has become. All right, next slide. Okay, so that is what is happening in the world of standards. At my center, while we help contribute to the standards development process, there are some particular areas of exoskeleton use and evaluation that we focus on. And I'm just going to highlight two of them over the next couple of slides. The first is on evaluating human performance for exoskeleton applications, really focusing on Army tasks. This is a series of work that is funded by US Army DevCom. Now, while this is looking at, specifically military applications of these types of systems, you'll see a lot of tasks that look fairly generic. Overhead tool operation, object lifting, walking on treadmills. These are basically leveraging a lot of the tasks that might be relevant also to industrial applications. When we do our evaluations for the Army, we do what is called a quick look evaluation, where we actually look at a very small N, typically 6 people, and focus on some element of Army operations, such as supporting and lifting tasks or artillery resupply. Andrew mentioned earlier a couple of the different objective and subjective measures that typically get used. We focus on those as well: metabolic cost, heart rate, skin temperature, and subjective measures such as the Borg rate of perceived exertion. Now, all of these measures are very important for understanding the impact that the system will have on the operation. Given that this is in the military domain and not in rehabilitation per se, we are looking for things that will reduce fatigue, that may improve their performance in some way, and that all depends on how you define performance. For instances like doing the overhead drilling or object lifting, we want to be able to do those tasks for longer periods of time before fatigue sets in. For long range marches, let's say for a lower body system, you may want someone to be able to carry more weight or just do it for a longer period of time before fatigue sets in. And there's also the element of acceptance. Acceptance by a military soldier cadre is different than giving it to a worker on the line or using it in a medical facility. And all these things get considered as we conduct our evaluations. Now, given that these are called quick looks, it is not intended to be a comprehensive evaluation of the system. This is really a snapshot of, is this system achieving some of the goals that it purports to? Is it applicable to this space? And based on these results, we can then dive deeper into, okay, does the Army want to further invest into this system? Do we want to feed some of these results back to the manufacturer so they can make improvements, et cetera? And all of these practices for the types of objective and subjective measures that we use here, these are not necessarily standardized per se, but they are common practice within the field. And all of the standards that are specified through ASTM will reference these types of measurements or this type of evaluation. So our results in testing will feed back into the standards process, and we'll leverage those standards wherever we can. Maybe just go to the next slide. This is actually not involving exoskeleton performance, at least just yet. This is where we take an application that currently does not involve any sort of wearable technology, where there's a thought of maybe exoskeleton integration could offset or mitigate some of the risks. And for this application, we're looking at explosive ordnance disposal, particularly people who have to wear EOD bomb suits. Now, I've only worn an EOD bomb suit once, but as I can tell you, and as I'm sure you can see, it's very heavy, very claustrophobic. Limitations on your range of motion, you get very hot underneath them, etc. And there's long been a desire to better understand the physical impacts of wearing one of these systems. So we'll conduct a similar type of study without an exoskeleton and measure the same type of objective and subjective measures to see what is the actual physical impact of wearing the system while performing relevant tasks. Based on the results of these studies, we can then look for exoskeletons that may mitigate some of those issues, such as supporting the back or the shoulders, whatever it is that kind of comes out of these evaluations. There is a publication that I can point everybody to. There's a citation on the right side of the screen there, if anyone wants more information. So those are just kind of two examples of the type of research we do in the center, and how we can leverage some of the standards that ASTM specifies. And yeah, I look forward to the rest of our discussion.
Perfect. Thanks so much, Adam. That was a great overview and very interesting work that you guys do. All right. So without further ado, I think we have a couple of questions that have come in so far that we'll answer live and sort of get your feedback on. I want to first talk about these standards that Andrew has touched on, Adam has touched on. What do you guys think about finding one unified consensus moving forward? How do we align OEMs, authorities, users, and companies to take these different standards and actually put them into practice in a way that's going to be beneficial for them? Hard to answer.
Jump in. Yeah, so from what the stuff that Adam was just saying, it seems like the ASTM is approaching standardization from a fairly different perspective, and it's much more technical, whereas the AFNOR that we looked at is much more high level and focuses on the workplace that wants to implement an exoskeleton, focusing on their integration strategy. And then maybe the ASTM standards can be used to craft that. So we've had some smart guys in academia come together and actually do the work for them, that they don't have to consider that themselves. You know, maybe they're not experts on how to measure robotics. I'm sure that they're not. But yeah, it would be, I mean, one thing I would like to ask, obviously your experience goes much, you've been doing this for much longer than your work in exoskeletons. You've been doing it quite a long time. From looking at other robotic devices like robotic arms, which have been around for much longer, these kind of cobots, where do you see as the next step? And what I mean is, in terms of working with regulators, so I think ASTM started out, you mentioned this project, Sabre, and then lots of companies in the civil space started seeing the advertisements and started seeing the news articles and thinking, wow, this could really help my guys at my workplace in the civil space. And they started reaching out to the, I think it was Department of Defense or the FDA, to say, how can we evaluate this? So, you know, say cobots are, what, 10, 20 years ahead of exoskeletons. Can you give us any indication of what might be coming over the horizon in the near future?
Yeah, so it's a great question. I think the biggest difference between at least the trajectory of the two types of systems is the human in the loop. I mean, as you guys know, it really is the X factor for all of this. And you know, it's one thing to get statistical significance when you're running a series of tests with a robot system. They're designed to run thousands of times a day, right? They can do lights out. They can run for overnight. You can conduct a repeatability test, and then collect your results in the morning. When you get into a human in the loop device, I mean, this is a thing for cobots as well, as we're starting to get, you know, truly collaborative robot applications, is there's many different types of people. And maybe they need to conform to maybe a narrow specification of height, weight, strength, you know, things that you would for, you know, any type of PPE. But it still is the kind of the biggest limiter. I think what's really encouraging about the field right now, though, and we've started to see this a bit in cobots as well, is so in cobots, you know, we started with the industrial arms that had no sensors, that were incredibly dangerous to be around, and those are still used quite a bit. But then it evolved into cobots, where we now have force torque sensors and you know, safety cages, et cetera, so people can interact with them. And from that, you're starting to see those get developed for specific applications. The same is happening in the world of exoskeletons, where you started with this full body suit of things that, more kind of movie-like. And now there are entire, branches of the industry that are doing upper body, lower back, lower body, ankle, knee, hand, arm. There are still some full body applications, but I think it's actually really encouraging that an exoskeleton company, and that science can support it in this way, can specialize into a certain type of system. And it's not just a system to say, okay, we're going to actuate the hand. It's always for a particular application or trying to improve a certain metric. And that's, to tie this back to Megan's question, that's really the role that ASTM has largely played in a lot of robotic spaces, is really focusing on testing and performance. So, the standard you brought up earlier about, how to integrate or kind of the decision matrix for, making a decision to integrate an exoskeleton. With that out there, I would imagine that ASTM would be like, okay, there's already a standard out there. We don't want to confuse people, but how can we fill in gaps or complement that standard? So, there was the evaluation phase, there was the risk assessment phase. If there are not already specified standards, say, within that document that, maybe already cover those things, ASTM would want to be pointed to, okay, go use our test methods or use these other ones that are out there. And I've seen that approach happen in several different areas. For example, on the F45 side, which again is on robotics and automation, we have not yet put out any specifications on how a robot system should perform, but there are existing safety standards that we then develop test methods to you use the test method to say that you met the specification. So it's really that kind of complementary nature, but it's hard to see the forest through the trees, right? When you see that entire map of standards. And there are efforts to try to bring all of those different groups together, even within the individual organizations. I know within ASTM, we have people who sit on ISO committees and, try to communicate it all back, because we want it to all work together.
Makes sense. Now, I have a personal question. It's kind of a chicken or the egg question. Do you think once we get further along in standardization, that's going to be the thing that helps open up the adoption of exoskeletons? Or do you think the challenge is going to become increasingly more of an issue, and then the standards need to come along to help with the adoption?
That is a great question. I think what's encouraging is that we are starting to see adoption of systems. Now, granted, they are largely by larger entities, your Boeings, your automotive industry, but that's where it kind of needs to happen first, right? There needs to be people who can have the capital and the ability to adopt. But also those companies are part of the standards process, which is, again, also really encouraging. It's not just them, looking at it in a vacuum. They're actually feeding that information back into the process. A lot of the test methods and practices through F48 right now, they will talk about system performance, but also risk assessment, training people to wear exoskeletons, labeling of exoskeleton systems, things that really do harken back to the use of the systems, not just the development of them. So it is really trying to be as focused as possible on the people who are actually going to adopt them. So I think they're kind of happening concurrently, right? Which is better than trying to catch up, which is more, I think, what we're seeing in some of the other robotics industries, just because they've been around for longer. Where F48, I think it's actually happening at a really nice pace.
Great.
Yeah, I think just to jump in there as well. So it's a question that always comes up. Obviously, we're approaching this topic as a manufacturer, and the topic of, are there any long-term studies? So can you prove that the device has been used long-term and there are no side effects, for example? And that's something that obviously when you talk about the chicken and the egg, people don't want to test it because they don't see the long-term studies, and therefore there's not going to be any long-term studies unless we step up and do it for ourselves. So I think this is also really encouraging, the work that's been done in standardization, where academia is stepping in to fill that gap and working with manufacturers, and obviously you have governmental agencies who want to test it as well, and even the synergy between how those two industries, so the defense can also support the civil space by actually doing those kind of long-term tests. But yeah, there have been some really great implementations that we've seen, and they are usually from the larger companies. So from what I've seen so far, the results have been very encouraging, very positive. But yeah, we'll have to see how it goes.
Yeah, and maybe just to complicate the matter further, what's interesting, particularly in the world of academia, is metabolic cost gets measured a lot, and it's a fine metric. And I would say, just to make a wild stab, in general, we see something like, let's say, 10 to 15% gain. Let's say for the right exoskeleton for the right application, and by gain I mean a reduction in metabolic cost. It offsets some amount. But what's not yet truly understood is, what does that mean? Okay, they're less fatigued. Great, that's good. But what is the impact on, and Andrew mentioned this earlier, task performance? Does it actually allow them to do things for longer? Does it have an effect on their cognition? Does it have an effect on their muscle atrophy for long periods of time? And these are being answered in small doses here and there. But you'll see in some of the F48 standards that are out there and that are being developed that there are focuses on things like cognition, like falling mitigation, things that really start to get into, okay, what actually happens while you're wearing the system outside of it does or does not reduce your fatigue? Because it's not that isn't an important metric, but it's just not the only one.
Yeah, makes a lot of sense. And I think that kind of ties into the AFNOR overall about deployment and administration, and how we want to know the facts of the matter, but there's also a human element, like you said, of overcoming objections of wanting to wear it, maybe in the older generations or newer guys who don't think that they need this kind of assistance. So I think it'll be interesting to see how, when more studies come available, if that mindset changes a little bit and it becomes more, the reception is there. Yeah, so I think we're it for questions right now. If anyone else has any questions, they can feel free to shoot it over in the chat, and we'll continue to answer once we get off. But want to say thank you again so much to Adam Norton for joining us today, and for Andrew for also shedding some light on the market and some of the specifications that are out there so far. Thanks, guys, for joining us today, and hope we can continue the conversation as more and more continues to come out.
Thank you very much.
Thank you. Okay, take care.